Our first vocabulary term today is defined as a single number. So single number or variable, or it could be numbers and variables multiplied. So it could be something like 3x, or it could be 33x. Those are all different types of this thing. And we call these terms. So a number, variable, or numbers and variables multiplied are terms. Going along with that, this next one is terms whose variables are the same. So maybe we have 10y and 7y. Those are each two different terms and they have the same variable. And we call those like terms. And those are actually words from last year, if you'd recall. Moving forward, it's a symbol for a number we don't know. That's really important. We don't know it yet. And it's usually a letter. So remember, those are things like our A. Our most common is X. Maybe it's a Y. And we call those variables. And I know we've used that this year and last year, so that should be nothing new. A symbol used for something we don't know. We typically use letters. However, if you want to draw a slice of apple pie, it'd be kind of weird, but it could represent a variable. Continuing on, a number used to multiply a variable. So if we would have a number, let's say 4, times our variable x, it's this number, 4, has a special name. And we call that our coefficient. This word, I know you might have heard it last year, but we're going to heavily use it this year. So know the coefficient is that number out front. And last but not least, a fixed value, or a number all by itself, is called a constant. And so if we had our equation, or our expression, y plus 3, this 3 right there is our constant, because it's a number on its own. Here are just more vocab words in a different form. It states an algebraic expression, which right there is our expression, 5p plus 4, has numbers, operations, variables, and all that good stuff. Each portion in that expression is our term. So one term is the 5p. The other term is the 4. They're separated by that plus sign in the middle. Within our terms, we see a variable, which is the p. We see a coefficient, which is the 5 being multiplied with the p. And we have a constant, which is that 4 off on its own. Just one more way of thinking about all of those vocabulary words. The first thing we're going to do today is to identify each of the parts of an expression. So we're going to identify our terms, coefficients, and constants. The first thing we're going to do is find all of our terms. Our terms are separated by all the addition signs. So if you go ahead and draw a line down those addition signs, we separated our problem into our two terms. Our first term is 5x. Our other term is 13. Notice we separate them with commas. Next, we have to find our coefficient. Remember, that's the number in front of a variable. Well, here, this term has a variable, and the number multiplied by that variable is my 5. That is my coefficient. And my constant is a number all by itself. In this case, it's the 13 that's all by itself. With part B, we first have to find our terms. And remember, if I draw a line through those plus signs, I separate my three terms in this case. My first one is 2z squared. My second term is y, and my third term is 3. When I look for coefficients, I want to look at things with a variable. And I have to pick out the number in front of my variable. In this first one, it's a 2. And then here, in front of the y, I have to figure out what's that number. Now, if I think about it, how many y's are sitting there? I have 1 y, and 1 is actually my coefficient. We just don't write it because it's not necessary. But it is actually there. And then lastly, we have our constant, or the number by itself. And in this case, it's the 3. It's that number off all by itself. Here I have a table for you to complete. You have to find the term, coefficient, and constant for these three problems. Your answers to number 1 will go in this first one, number 2 in the middle, and number 3 down on the end. Please pause the video, complete the box, and come back and check your answers. Looking at my table, you'll notice that for number 1, we had 2 terms. The coefficient was 10 and the constant was 12. For number 2, I had 3 terms. My coefficient was 3 and I had 2 constants. They were 15 and 1/2. And with number 3, I had 2 terms. My coefficients were 9 and there was a 1 because the 1 was in front of my z squared. And in this case, there were no constants. So now that we figured out what terms are and constants and coefficients, we are going to go ahead and combine our like terms. And remember, like terms was one of our vocab words we talked about. And it's a word, what they are, they're terms with the same variable. Okay? So we're looking for things with the same variable so we can combine them. But before we do that, when I look at a problem, so looking at number A, anywhere I see a minus sign, I like to change it into plus negative. And I do this because then I remember if things are supposed to be negative, and I can move things around without causing a disruption in my math. And that's why I'll be likely to make fewer mistakes. And then what I want to do is I'm going to go ahead and highlight the things with the same variable. I notice sticking out to me, I see 4x. It has a variable, and then I want to see if there's anything else up here that has an x. Well, I see there's a negative 2x, so I'm going to highlight that as well. I have a left, an 8, and a negative 12. And those actually have the same variable with the fact that they don't have a variable. We have 2 different constants. So I'm going to go ahead and highlight those. And now that every single term is highlighted, I can go ahead and start combining things. I'm going to start with the things that had a variable. 4x plus negative 2x. We have to combine the coefficients. So we have to figure out what is 4 plus negative 2. Well, it equals 2, and the variable stays the same. So 4x plus negative 2x is 2x plus, and let's cross that out, I'm going to then combine my constants, 8 plus negative 12. Remember, put yourself on the number line, and we end up at negative 4. We use both of those, and here we have our simplified expression, 2x plus negative 4. Those are not like terms, so we can't combine them, and so we are done. part B is a little different. I can go ahead and start by changing my minus signs into plus and negative. That's a great way to start every problem. And then I have to think about this. I see a negative out front. But remember, with those parentheses, we have to do something special. We want to get rid of those parentheses. And when we see them, we're going to use the distributive property. Okay, so we have to think about what number's out front, not just negative. It's actually, remember, a negative 1 is sitting out there. And we have to go zoop and distribute it to those things in the parentheses. So my first arch is going to give me negative 1 times 2x. And when we multiply these, we did this last unit. We take the numbers and multiply our numbers. Negative 1 times 2 is negative 2. Variable doesn't change in this case. And we're going to add that the second zoop. So zoop, we're going to multiply negative 1 times negative 5. Negative 1 times negative 5 is positive 5, which we've learned. And then I have plus negative 7 still. So, now that I've done my distributive property, I can go ahead and combine my like terms. So let's first go ahead and pick out things that are the same. Here I have an x. I don't have any more x's, so I'm done with that. And now here I have a constant, a 5. And my negative 7 is also a constant, so those are like terms. So negative 2x didn't change at all. And then I'm going to add to that 5 plus negative 7, which lands me at negative 2. So B simplifies to negative 2x plus negative 2. And last but not least, I have part C. C, we're going to go ahead and change any minuses into plus and negative. Then we're going to go ahead and do our distributive property. So I'm going to take negative 4 times 3x, which gives me a negative 12x. And to that, I'm going to add negative 4 times 2, which is negative 8, and then I have plus negative 10 on the end. I'm going to go ahead and highlight my like terms. I have my negative 12x, which has no other terms like it. And then I have a negative 8, and its like term is a negative 10, since they're both constants. Now when I go ahead and combine these, negative 12x hasn't changed. And then that's gone. I'm going to take negative 8 plus negative 10. And that ends up with being negative 18. Now here are 6 problems to try on your own. 3 are like letter A on the last slide, and the bottom 3 are like letter B on the last slide. So please pause the video and give these 6 a try on your own, then come back and check your answers. So looking over our answers, for number 1, it combined to 4t plus 8. Number 2 combined to 7t plus 6. And number 3 became 8n plus negative 4. For 4, 5, and 6, we had to use distributive property before identifying like terms. And I ended up with 4x plus negative 5 for number 4. Number 5 was negative 1x plus negative 30. And remember here, if you want to write just negative x plus negative 30, that's actually a little better. But I'm okay with the 1. And number 6 ended up being 3x plus 2.